All right, problem 87. We have the velocity of this particle given by this equation here, the natural log of t cubed plus 1. We got to find the acceleration at time t equals 4. This is actually pretty simple because as long as you know the acceleration is the derivative of v, or that acceleration is the derivative of velocity, all you have to do is take the derivative of this and plug in 4, evaluate it at 4. So we just want to find v prime of 4. And since this is calculator based, we can just use our calculator technology. So let me just go through it again on here. So the numerical derivative at a point. So our value will be 4. Our function, the natural log of x cubed or t cubed, same thing, plus 1. We get about 0.783 or 0.738. So the answer is A. Or 88. So the function f is differentiable and f of 4 equals 3 and f prime of 4 equals 2. What is the approximation of f of 4.1 using the tangent line to the graph of f at x equals 4? Okay, so these ones are actually pretty simple as long as you can just think and realize that, remember, the derivative is just a slope. It tells you what the slope is at a point. In this case, it's telling you that the slope at point x equals 4 is 2. So we know that we have a point at 4, 3. And if you want to estimate what the value will be when x is 4.1, so you're quite literally just going to, change to the right 0.1 units. So you're going to be at 4.1, but you want to know how much up you go. We know we're going up because we're going up at 2 units, but it's 2 units. This is, well, 4.1. Let me put that. The logic is you're going up 2 units per every full unit. You're going up at a ratio of 2 over 1. So you're going up essentially 0.2. You're double, the formula, I mean, if you want to look at it as a formula, what you do is just take f of 4, then you add it 0.1 times whatever the slope is, times 2. And then you'll get 3 plus 0.2 or 3.2. As long as you don't overthink this, they're pretty easy. And I always recommend when you're learning this, maybe start by drawing graphs, pictures. Again, on a test, you may not want to waste so much time, but all it is a slope. You're going up by 2 units. For every 1 unit you change in x. So if you're changing by 0.1 units, you're only gonna go up by 0.2 units. All right, 89. Patrick is climbing stairs and the rate of stair climbing is given by the differentiable function s, where s of t is measured in stairs per second and t is measured in seconds. Which of the following expressions gives Patrick's average rate of stairs climbed from t equals 0 to t equals 0, from t equals 0 to t equals 20 seconds? Okay, so the key is average rate of stairs climbed. So since we are taking the average from 0 to 20, we know we're going to multiply this by 1/20th. If you remember, like, you probably see the average value function, which is equal to 1 over, let me just write it out formally, but again, if you understand it, you don't even waste your time memorizing 1 over b minus a from a to b of whatever the function is. So b minus a, 20 minus 0 from a to b, so from 0 to 20. And then we just have to make sure we understand which function goes here. Is it going to be s of t or s prime of t? Now we're already told, see, we're told that this is the rate of stair climbing. So then we just need to have s of t because we're integrating the rate. It could just kind of be misleading because it's not s prime of t, but it's still a rate given. So then it would be, our answer would be B. And the last one, so let me zoom out so we can see the whole thing more easily. So the graph of f is shown here. Which of these statements is false? Okay, so let's just go through each one. Try this best way. Whoops. Okay, so f of 1 is f of 1 equal to the limit as f is equal to the limit of f of x as x approaches 1 from the negative sign. You can barely see it, but as x approaches 1 from the negative side. So what's the limit as x approaches 1 from the negative side? Well, we're coming from here to 1. So the limit is this value. So this is equal to 2. But what's f of 1 equal to? If you look here, there's an open circle at 1, comma 2. So f of 1 is actually not equal to 2. F of 1 doesn't actually exist because there's no point on the graph when x is 2. So this is actually, does this f of 1 does not exist, or it's undefined. And that's not going to be equal to 2. So right away, the first statement is false. It's going to be A. That was simple. All right, so I hope that helps. I'll see you guys in the next video where I'm going to go over the free response section. All right, so I'll see you guys then.